All right, in this lesson, we're going to take exponents a little further into negative exponents, which is something you've probably not seen before. But keep in mind, math rules don't change, so you already know the principles behind this, because math is just addition, subtraction, multiplication, and division used in different ways. So let's look at what I'm talking about here. So let's stick with the example of 2 squared. So that's a positive exponent. That 2 for the squared, the exponent is positive. So that's the same as saying 2 times 2, which is 4. All right, well, what if the exponent was negative? What if we had 2 to the negative 2 power? Now, one thing you need to keep in mind is that this negative is a little bit different than like if this was a negative 2. A negative 2 and a negative integer and a negative exponent are not exactly the same thing. So if a positive 2 means to multiply, what do you think a negative exponent would mean? If you said divide, you are absolutely correct. So this is really the same thing as saying 1 divided by 2 squared, which is 1 divided by 4. So instead of multiplying here, we would divide. So let me go back and put in that last step. So instead of instead of 2 times 2, it would be 1 over 2 squared, which is 1 over 2 times 1 over 2 equals 1 over 4. I didn't want to skip that middle step and confuse you. I want to show you every step. So the negative exponent, instead of multiply, it means you're going to do the inverse, and we're going to divide. So we're just going to flip it over. All you're going to do when you see a negative exponent is flip it over. So let's look at a couple more examples really quick. 3 to the negative 4th. If you have a negative exponent, we're just going to move it to the other side of the fraction bar and make it positive. That's all there is to it. Because now we're dividing multiple times instead of multiplying multiple times. Or what if you have one that's already in the bottom? For example, we know that we could do 1 and 3 over 4. What about 1 over 2 to the negative 2? Now you're looking at a whole different thing here. Or at least it looks like it at first, doesn't it? Well, anytime you see a negative exponent in the bottom, you're going to move that to the top. And 1 times anything, of course, is just itself. So now it becomes 2 to the positive 2 and no longer a fraction. So if it's in the bottom, it moves to the top. If it's by itself, which technically it's in the top of a fraction, we just don't write the bar in the 1, then you move it to the bottom. So you're going to do the opposite. It's a little bit different than a negative integer or negative sign on a number. So let's look at a few examples. All right, and you read these problems carefully. It does not want you to actually do the math. It wants you to write it as a fraction. So you're going to write it as a fraction with some number on top and some number on the bottom. And you need to have a positive exponent. It says do not evaluate. If you type this in your calculator is going to crash because 45 divided by itself 34 times, or I'm sorry, 1 divided by 45 34 times is going to be so small, it's basically just going to give you either a 0 or an error. So again, we want to make this positive. All we do is move it to the bottom. And then since there's nothing in the top, we just put a 1 up there. And I don't think you'll see any in this one, but just in case you're wondering, so if we had 2 squared times 2 to the negative 2, then we would put, this one's positive, so it would stay on top, but this one's negative, it would go to the bottom. So you can split them up like that, as long as you're multiplying. If you're adding or subtracting, it's a little bit different, but again, you're just moving whatever has the negative exponent, you're moving it to the other side of the bar. If it's on top, move it to the bottom. If it's on the bottom, move it to the top. All right, I know this is a little bit confusing because you haven't seen it. I will add another video underneath from Khan Academy that I think explains why you move it much better and a little more detail if you want to watch it, but I wanted to get some examples first. All right, I switched the slides, so this is probably what kind of questions you'll see first, but I wanted to do the other one to show you that it didn't matter what the numbers were. However, this time it says what is equal to 1 divided by 9 over 6. Now, you could go through and figure out each one of these and see what's equal, but I want to point out a couple of things. Number one, there are no negative signs. There are no negatives in here at all. Again, the exponent negative and the negative in front of the number are two completely different things. It's very, very easy to get this confused because you just recently, in 7th grade or so, learned about negative numbers, and now we're throwing in negative exponents and telling you it's a little bit different. The 9 itself does not change. Okay, when we're working with just the exponents, we're not doing anything to the 9 to change it. So anything that has a negative in front of it is automatically disqualified. So I want you to understand that those are different. The only thing we're looking at are the exponents. Now, having said that, let's look at what we actually do here. So let's move this one around a little bit and see which one it looks like. So we're going to move the 9/6. I'm sorry, not 9/6. 9 to the 6th. We're going to move it to the top, and it's going to change the negative for the exponent, not for the 9. It's still 9. So instead of 1 over 9 times 9 times 9 and so on, now we have 9 to the 1/6, which is again the same thing, 1 over 9 times 9 times 9 and so on. So I know this one's tricky, but if it's got a negative in front of the integer and it doesn't have one in the original problem, that's not how it works. You don't change. The 9 stays 9. The 9 stays positive. If it's positive up here, it stays positive down here. Only the exponent changes today. All right, again, if you try to type this one in the calculator, it will definitely crash. If you multiply 226 times itself 615 times, you're going to have, I mean, you're not even going to be able to do that on paper, much less in a calculator. I don't think even the biggest computer could do that. That's going to be a number just tremendously large. However, it is not asking you to do that. It is asking you to write the expression as a whole number with a negative exponent. So a whole number, 226, and we're moving it to the top to make it negative, 615. And we're moving it to the top of the bar. So we're moving it up here, and we're going to make it negative. All right, and like I said, I'm going to include a Khan Academy video for this one. He takes longer to explain the same thing I explained, so if you have any questions on why a negative actually means divide, hopefully that'll help.